test. Well, let's look at a few things. First of all, let's review a few big ideas before we move on. The quotient rule is on the test, and although most people are fine with the quotient rule part of it, which is when you take the derivative of a function over a function, it's done by a mnemonic, what? Low, G, D high F prime, minus high D low, over the square of what's below. Okay, now, in that case, most problems you're doing fine on. There has been this little subset of problems where it's been a little learning curve. You can use to find the second derivative implicitly. And so I want to practice that. Would you go before we can? Actually, I'll put that in a second. I mean, we should hit it right now. Will you go to the back of this? There should be a little room at the back, at the bottom. Is there a little room at the back at the bottom? A little bit? Yeah. Go below the notes review tomorrow before school if you're interested. And would you try this problem here? Given x minus 2xy plus y squared equal 1, find dy dx first, and then find the second derivative. Try that, please. Try that. The first derivative should not require the quotient rule. The second derivative will. Just to make sure, if you're iffy, make sure that you don't go too far off in the wrong direction by checking your first step. If you had part A, then you should continue on to the second derivative. If you didn't have part A, your derivative right, then you should correct it before you move on. Yes. Your final answer should be in terms of x and y, not dy dx. Okay, so making sure you're all good. The first derivative, any questions on the first derivative? Okay, catching up to you then, the second derivative means take the derivative again. So on the left-hand side, the derivative of the first derivative is the second derivative, that's the goal. And on the right-hand side, we have quotient rule. That's one of those cases where the quotient rule is going to be tested tomorrow. Low d high. What is d high? What's the derivative of 2y minus 1? 2 dy dx. Anytime you take the derivative on the y term, you're going to get out dy dx. Minus low, or high, rather, sorry, d low. What's d low? 2 dy dx minus 2 over the square of what's below. That's all cool. Okay, now your answer is in terms of the second, or x's and y's only. So the only other thing you have to do is replace every dy dx with what? Yeah, that. Okay, the derivative 2y minus 1 over 2y minus 2x minus 2y minus 1, 2, what a mess, 2y minus 1 over 2y minus 2x minus 2 all over 2y minus 2x. Okay, so quotient rule, that's as bad as it's going to get. Yes? Absolutely not. Total waste. Okay, please don't. Going back, sorry, back to the notes section. Rational functions. For the most part, these are going okay. In terms of some of the big ideas, remember, if you look for holes first, there will be vertical asymptotes if what happens? Denominator is 0. There will be x-intercepts if what happens? Numerator equals 0. How do you find end behavior? The limit as x goes to infinity of the function. And remember to write that as an asymptote either, or as an equation, either y equals a constant or y equals 0 or something like that. Remember end behavior for other asymptotes. And then there's all the sign testing components to when it changes sign and when it doesn't. Hopefully that'll go. Normal line. Let's go to the second, or sorry, I guess it's set 40. Normal line. How is it like a derivative, or like a tangent line? Like tangent in that what? Say again? You need a derivative for the slope. You still need a point and a slope. So you're still writing the equation of a line. You're still finding a slope. You're still using a point. How is it different? Yeah, the slope is the opposite reciprocal of the tangent slope. It's perpendicular. Normals are perpendicular. Okay, so it's just like a tangent line, except for the slope you take the opposite reciprocal. Interpreting the derivative. Interpret the derivative. These will come in a word problem form. I would suggest, if you're iffy on that, look back at examples or notes from set 40. We did lots of those problems in class where we talked about writing it. But when you interpret, say you find A is the amount of something at time, amount at time t, then A prime at t, when you find it, actually let's call it A prime at an instant, at some, whatever, at some time given. First, I would suggest you think of it instead of A prime, think of it as dA dt. To remind yourself, hey, this is a rate of change. Change in amount with change in time, not just A prime, which doesn't really say it like that. Thinking of it that way reminds you, hey, it's the amount over time, the units on the amount of this, the units on time of that. It helps you in a lot of ways to think about it that way. Second, you must interpret the sign. Not change. Don't tell me the amount is changing it to centimeters per second. I want the change, the amount is increasing or decreasing by 2 inches per second at a rate of 2 inches per second. Okay? It's a specific thing, and that is in keeping with the AP test. Did you have a question, or did I answer it?
I was a handwriting thing, but I did.
Okay. That's definitely going to happen.
I read the word backwards and it made more sense.
Oh. So make sure you are specific about how it's changing. It's a rate. DADT is a rate of change. So you should be saying it's the rate. Rate is a key word in there. It should be in there. The rate at which the amount is changing or increasing. Okay, it's a rate of change. And last, don't forget the units. Use DT units, use A's units, and T's units as a guide. It should be a rate with those units in your rate. Inches per second, meters per day, whatever it might be. Okay? Pounds per, problems per minute. We'll practice that in a second. On 39. Sorry, I probably spaced this terribly. Figure out a place you can make these notes happen. Estimating area by rectangles. Now this is finite rectangles, not the infinite rectangles we've been doing lately. It's just finite. Equal subdivisions seem to be doing okay. I expect you to be able to do left, right, and midpoint. Upper and lower. We'll eventually get back to those, but left, right, and midpoint right now are the stars of the show. Equal subdivisions have been in the homework, and for the most part they've been going pretty well. Please make sure that if they're equal subdivisions, you can factor out the base, because all the bases are equal subdivisions. That's a common factor. Make sure for the heights that you show not just the numbers, but where they come from. F at 1, F at 2, so on. I need this. That's required. Make sure you show that and don't get in too big of a rush. I don't want to see 5 plus 7 plus 9 in there. I want to see F at this plus. Okay? That's how I taught you, and I expect you to show that. Unequal subdivisions. We haven't had a lot of practice like that in the homework, in the problem sets, but if you look at extra practice 39, there were a few practice problems in there. That usually happens when the function you're working with isn't friendly at normal intervals and you're without a calculator. So for example, square root from 0 to 16, you wouldn't go 0, 2, 4, 6, 8, because 2 and 8 don't square root, right? You might go 1, 4, 9, 16, because they do square it nicely, but those are unequal subdivisions, okay? Also, over-underestimate. I want you to be able to justify, to tell me, all right, I got this estimate. Is it more than the real area under the curve or less? And to say it well, again, trying to prepare you in an AP requirement. So give me 2 cases where rectangles will overestimate. My area is an overestimate because, or if, what? Functions, if we use increasing function with what kind of rectangle? With right, I agree. Pictures help so much. Think of an increasing function and think of maybe 2 subintervals. And if it's increasing, isn't the right more than the left? And so that'll be an overestimate. So you would absolutely overestimate if you had increasing with right hand. In what case would you get left hand? Overestimate. Decreasing with left hand. I think you'll see that if it was a decreasing function, then the left side is greater than the right side, so left hand rectangle. When you justify it, it needs to be said this way. It's an overestimate because I use right-hand rectangles on an increasing function. I don't want to hear kind of an informal, because my rectangles are above the curve. Yes, that's true, but that's not going to cut it, okay? Your eyeballs are never going to cut it as proof. So say it this way. Although you probably can figure it out, let's just get in our notes. Underestimate if what happens? Decreasing with right hand or increasing with right. For midpoint rectangles, we don't typically get into that until we get to capital, so don't worry about midpoint cases. All right. Again, set 39 extra practice, which was stapled and was yellow or gold. That might be a good thing to look over if you're worried about that. The back page of that extra practice, by the way, where you interpreted what the area means, we're not there yet, so I will not be assessing you on that yet. All right. 38, integral of a sum is fine. If you have the integral of f and g, can you integrate each term separately? Is that allowed? It is allowed. You may separate the integrals, okay? Other idea, that's just a quick fact, this. Power rule? No, special case. What's the antiderivative of that? Natural log, now be careful. Absolute value, okay? And then, if you're one of those knuckleheads that lost 3 points because you forgot plus C over and over and over on the last test, I hope you learned your lesson and you will remember your plus C. Sorry about the knucklehead comment, but you are a knucklehead. All right, last big thing on the idea is differentiability. 37. What are the 3 reasons why something would not exist, a function would not be differentiable, which is to say the derivative doesn't exist at that point? What's one? Sharp turn, yep. Must be locally linear for the smooth transition of slopes from one to the other. Give me another one. Discontinuity. You cannot have a derivative at a graph to a point that doesn't exist on the curve. And vertical tangent. Be careful not to say vertical asymptote. Not the vertical asymptote's not great, but vertical asymptote is the discontinuity. We've already got that. Vertical tangent. Think this. The old implicit derivative. When we did vertical tangent, doesn't that imply that the rise is something, but the run is nothing? And so vertical tangent's a problem because dy dx has a 0 in the denominator, which breaks them up, right? Other topic, critical number. Looking at a homework that I just graded, this had some errors that people didn't catch. Critical numbers. Give me the definition of a critical number. X equals C is a critical number if, or what happens? How do you find a critical number? Okay, let's get the most important part, please. Critical numbers are numbers in the domain. Underline in the domain where the derivative is 0 or undefined. There was one on the homework on the back. I can't remember which one. But it was find the critical numbers of that. Okay? So I imagine grading this, most of you would probably, or the people, a lot of you would have got about half credit on this. Okay? Because you didn't do the first step, you just started with the derivative. And you said something like 1/2 x squared minus 4 to the negative 1/2 times 2x. And you cleaned it up, and you got this, yeah? And then you said, all right, the derivative is 0 if, so a fraction derivative is 0 if what happens? If if the numerator is 0. So this derivative would be 0 if x is 0. It would be undefined in fraction form if the denominator is 0. So that would be, in this case, x equals plus or minus 2. So they did that, and they said, boom, there's my critical numbers. Yes or no? No, because they didn't remember that part. So in terms of how I grade this, first thing I did is finds domain. What's the domain? Did this person find the domain? If they did, they didn't write it, so I can't see it. What's the domain? Greater or equal to 2 in order to stay positive, or less than or equal to negative 2. Okay? Finds the domain. Check. Last. Only chooses critical numbers that are critical numbers. In other words, is there something going on interesting at 0? No, 0 is not even on this graph. Okay? So please don't say it is a critical number at 0 when 0 doesn't exist. Please check that your critical numbers are actually on the graph. That's what makes it a critical number. I don't want to go and say, hey, there's something interesting at 0 when 0 doesn't even exist. Okay? So make sure you start and end with the domain on a critical number problem. Few practice problems then. I will put the key to this online, but there's a few I felt like they were good practice. Would you try 1A, either on this paper if you have room, which I don't know if you do, or feel free to do it on other paper if you like. Talk it over, ask questions. These are the ones that I'm going to have do the ones in class that I feel like are most likely to trip you up. This whole problem should be no calculated, by the way. Tripped up. When I read this carefully, local maximum and min values of G. At the end, should I be saying I have a max at x equals -1? As answer the question. It says, what is the max value of the function? You should be getting a y value. Okay. And where they occur, if you want to overachieve. But you must find the y values at the end. And that would, on a 9.8p problem, usually cost you a point. So let's start here. The domain, I would normally worry about the domain, but because the denominator is never 0, it's not really a sweat. You could say x is all reals if you like, but it's not a critical number problem, so if you didn't write that, I wouldn't count off there. That's good to think about. The derivative, I assume, I actually shouldn't assume, did the quotient rule part go okay? Does your derivative look something like low, b high, minus high, d low, over the square of the square low? Does your derivative look like that? Okay. This question would probably be up to about 10 points, and that would be 2 and 3. After that, you need to start figuring, all right, max and mins are where the derivative is 0, or sharp turns could also be places where you get a max or a min. So we typically will focus on where this is 0 or doesn't exist. So let's continue on. If I clean this up, I get x squared plus 1 minus 2x squared. So I wrote it that way. You could write it negative x squared plus 1 is fine too. But do you agree with that cleanup step? Yes? You might be able to see the zeros are at 1 and -1, and I could too, but in terms of sign testing, maybe it's easier to write it this way, maybe not. I typically like it factored to sign test on. It's just easier to sign test. So I get critical numbers at x equal 1 and -1 for the top, but any zeros in the denominator? No. All right. So I move on to my sign test. -1 and 1. The signs of G prime. If you had those zeros, what signs did you get in the three intervals? negative, positive, negative. That would imply, I agree, that G is decreasing, increasing, decreasing. So something like boom, boom, boom. Oops. Let me try this again. Boom, boom, boom. Like that. Something along those shapes, yes? All right, and now here's where we answer our question. So -1 is most definitely a minimum, but let's answer the question. It says, what are the local max and min values of the function? Yes?
Do we have to write the G prime G and then that?
No. I don't grade for the sign test. That's really for your benefit. So do as much or as little as helps you. You're welcome. That's a good question. I'm glad you asked. I do, however, need the y value because the question, although not super hammering you over the head, it is in there. It says find the values of the function. So besides just saying there's a min at -1, I need to find what g at -1 is. Common error is where do I put it in? Am I putting it into the function or the derivative? Function. I'm looking for points on the function, all right? The derivative would be silly anyway because what's the derivative at that point? It's 0. That's how we find that point, is we set the derivative equal to 0. So that's not an issue. I want to find the function at -1, a point on the curve. -1 over 2 is the point. So my conclusion, my wording would be something like this. G has a local min value of, not at, of -1/2. I'm a cover my tush kind of guy. And so I also parenthetically say at x equal -1. I know they didn't ask for where does it occur. Sometimes they do. So I'm just making sure, you know what? So local min value of -1/2, which occurs at x equal -1, because g prime changes from negative to positive. Okay? As far as how far it increases up to and what the y, yes, sorry.
Can you write that in coordinates form?
So this is actually a good question. That's the way I did it the first time. And I asked Mrs. Law, who was my kind of AP grading mentor, and she said it's often deductive for on the AP test because it puts the onus on the grader to figure out the answer to the question. It makes the grader say, this is the minimum value, so it's safer to do it this way. Okay? G has a local max value of, I think it's +1/2 at x equal 1, because g prime changes positive to negative. Okay? Yes?
Do you have to specify local max or min if you say like at x equals -1, there's a minimum value?
That's a good question. The AP is pretty liberal as far as that goes. Besides the fact that we haven't covered absolute versus local min. Basically, it's this. There's two types of minimums. There's local and absolute. So, for example, this is a local max. This is an absolute max. It's a good habit, but right now I wouldn't count off there because, you know, we don't know the difference.
Would they count?
They wouldn't on the AP test, but professors often would.
Okay.
That's a good question. Yes.
Can you review the language that the question will ask if you need to find the y values or just the x values?
Yes. So the common wording is, this is pretty common wording for when they want a y value. If they say, find the local and minimum maximum values of the function, blah, 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 then it's implied y values. They will often say, find the local max and min values of g and where they occur, in which case you're giving y and x, and in that case coordinates would be okay, or this also would cover it, okay? When they say, what's the value of the function, that's the y value, and if they say, where do they occur, that's the x value. And if they ask for both, then you get both. If they're trying to save time, then they'll say, find the x values at which the minimum and max values occur, and that's really just, I mean, that's obvious they're saying it to you. Okay? It is pretty subtle. The graph, although rational functions, I pretty much have no problem with rational functions, at least the ones in the book. This one's a little funky. So I think it's worth your time to graph it now. It's not straightforward. Try graphing it, obviously, without a calculator. To get the best picture, use all the tools in your kit: poles, vertical asymptotes, x-intercepts, derivatives, zeros, end behavior. Yes? Yep. Really, after this stage, it's up to you how fast you go. This is going to grade 4, after that, it's up to you. Okay. I didn't ask for it, but what are the equations of the asymptotes of y equals 0? There it is. Remember, don't get locked into vertical asymptotes only. There is almost always an end behavior asymptote. In this case, as x gets large, this goes to 0, which implies y equals 0 is an end behavior asymptote. All right, so you do have a horizontal asymptote. It would have one, no vertical. So I have these 3 points, and I have this asymptote. It follows. What is it? Connect the dots. What does it do? Use the derivative test. This is gold, baby. Decreasing up to -1. So it follows this asymptote, and it decreases to -1, -1/2. So what does it look like? That. And then what's the derivative at -1? X equals -1. 0, so the graph goes flat. It decreases steadily to there, and then, I'm having trouble drawing that. What does it do between -1 and +1 in x? It increases. And then after 1, the derivative is negative, so it decreases. And we have maxes and mids, and all that's good. Calc honors people, what's going on with the second derivative in the graph? It's concave. Up before, down, and what do you call that when the concavity changes? Reflection. We'll cover that next week. Okay, that's obviously not for right now. Okay, good one. Another one, I felt like this is not, I think in the interest of time, I would like to go to this guy. Would you go to 5, please? This would be a AP style problem in multiple parts. It's no calculator up to part D. On D, you can use a calculator, but all the others, no calculator. And please take it to heart when I say leave your answer ugly. I'm not wasting any time simplifying your answer. like to talk about pieces as we go, or just do the whole thing and talk about it at the end? Okay, sounds good. I'll just walk around and point you in the right direction. If you have questions. Or feel free to talk it over. Yeah. Aren't they born when they hatch?
That's not birth. That's laying.
Okay.
You have to rewrite this.
Hatched. Okay, I will. Since it was hatched, that would be correct?
Yeah,
Okay, cool.
just fact checking you.
I appreciate it. I would like it to be as good as it can be, so I will change it later. Since it hatched.
What is the time that a lizard is? Oh, wait,
I would, if you're having trouble with B, you might consider writing that E term just slightly differently, and it'll help a lot. If you have something hideous for part A, then you're probably doing it right. Or at least on the right track. Is it? I kind of made it up on the fly. I was doing my best. I don't know what the way that lizard is. I guess it could be. It could be. Yeah, it's good lizard. That's okay.
We support all types of lizards.
Yeah, we're not going to discriminate against lizards. Whatever you want. You do not have to simplify your derivative in part C because the interpretation elements of B is calculator.
Which is the upper level.
Yeah?
That's not just about beat, right? So how you rewrote it and everything.
I haven't finished rewriting. I didn't want to do it for you. That's not what I didn't mean write it like that. That's not.
Okay.
So what's a good way to write the e? E to the negative t is the same as 1 over e to the t. So if you wrote it this way, then, gosh, then you do a ton of thinking inside out. what does e to the t go to?
Yes.
As time goes to infinity, e to the t goes to big. So what does this go to? Small. So what does this go to? So what does this go to? So what does this go to?
56.
42. Goes to 42. His weight approach is 42. Okay? Or its weight approach.
I just showed that one.
How would you? You would. I would expect to grade just the answer. Yeah. Okay? Now, you'll see if you were to look at the shape of this, for you bio people, the shape of this is actually one of the more famous differential equations ever.
But as for
Okay, this is logistic growth. Math people call it logistic growth. It does. If I said how many coyotes could that field approach, you'd be talking carrying capacity. Carrying capacity is logistic growth. If I said how long does it take for a fad to spread, carrying capacity. A social scientist would use logistic growth to talk about the spread of a fad. A biologist would talk about the spread of a disease, carrying capacity. All this curve is super duper famous, and you can see the limit as time goes to infinity is the true key piece to it. All right, so this is 42 pounds. Sounds good. I'll put up my answer to A, and you can see if you have the same. And so, did you get something like the opposite of the natural log of 56/34 minus 1 all divided by 3?
I am very close, friends.
1150. 11? Oh, if you simplify? And that is in months, by the way. Units of length. And when I say simplify, I mean simplify nothing. Waste no time on arithmetic. None. If you like. Okay? D or C, did you get the derivative? Did you have some kind of quotient rule component? 0 plus, or did you call this, some might call this 56, 1 plus 3e to the negative t to the negative 1. Did you bring it up and use chain rule kind of thing?
Yeah.
Okay, that's fine too. If I use quotient rule, then it's low. So there's this d high is 0 minus high 56. The d low, check at some point you had to take the derivative of that. The derivative of that is 1 plus 3, oh no, sorry, not 1 plus. The derivative of that is 3e to the negative t for the derivative of the e term, but you have a chain rule. So then did you multiply by the derivative of negative t, which is negative 1. Did you do a chain rule on the negative t? Yes? No? Okay. So if you simplify, which you did not have to do, maybe something like 168 e to the negative t positive over 1 plus 3 e to the negative t squared. I know I'm supposed to be in study hall, but just let's finish part D. Okay, did anybody get to the numerical answer to W prime at 5? 168?
No.
Oh, sorry. At 5,
1 oh, yikes. 132?
1.320?
1.132.
132, sorry, okay. Okay,
that's a fast blizzard.
this seems to make more sense in the context of the problem, but I could be wrong. W168, let me check this real quick.
Well, that would be, that's talking about how much weight you gain.
Yeah, the rate of change in the weight.
And his,
Eight,
sorry.
8 to the 5 divided by 1 plus 3 to the negative 5. I got 1.087. What the heck? You did?
I got negative.
Negative should definitely not happen because I know that he's not losing weight. Okay, let's assume 1.087 is okay. Okay, now this interpreting then, if you call this W dt, as I suggested, instead of W prime, it might be helpful to say that's change in W, which is change in weight in pounds, over change in time, which is in months. So interpret, please, in a complete sentence. Start by referring to the time. At time equal 5 units, months. Anytime you throw a number in there, you should be attaching units to it in a column like this. The lizard is, now you can either say increasing his weight or gaining weight, both imply the sign. Increasing weight, gaining weight at a rate of 1.087 pounds per month. Okay? He could be.
Yeah, he would get to 42 pounds.
Yeah. All right, that is the idea. Okay? The rest of the problems I'll put on the my key on the website, and you can check to see how you did. I'll also be happy to review before school. I don't have as many people from this class coming to those reviews, but there's a lot of honor students in here. But let's say the other class doesn't have quite as many honor students, and they hit those reviews pretty hard. So if you feel like you can brush up on a few things, or you want to practice on anything on this, either look at the notes for these lessons or come in for extra practice. The rest of the time, the study hall. I'm sorry to interrupt you. What?
Are these due or is it just the
This is meant to be for your benefit, so do as much or as little as helps you. It will not be collected. I cannot allow that. Sorry. As much as I would love to go outside. It is a lovely day.
Mike allowed us.
Yeah, Mike took us outside to play
Both
frisbee.
Mike's in charge of your safety. I'm in charge of your.
No, the other Mike too.
What other?
The actual Asian.
The actual Mike?
The actual.
The fake Mike and actual Mike?
You're
You're a closer
the
Mike.
Asian.
You're not a real Mike. The Asian Mike? What does that even mean? Which one is it?
Yeah.
Ethics Mike is not real Mike?
No.
No,
Fake Mike.
Yeah.
well, he's not fake, he doesn't
Fake.
exist.
No, Brian says he's fake. He's a fake Mike.
Sure, Mike is.
We Snapchat all the time. Fake time was like, I just don't get you, Rachel. I'm like, you never know.
I feel like
I don't think you should ask.
so. To answer your question, no. Didn't I just show you exactly what to do? Just do what I did. All you gotta do is do what I did.
I know. It is like gold. I was like, how do you take it from like 1 to right?
So,
I
well, that's what it was for me. I am going to take, I am not going to take off. Take care of this. You deserve something. I think it's being spend 20 minutes
Yeah.
and go. So, it's up to you. That's all great things were accomplished by saying, screw it, I don't really care. All right.
Kind of silly.
Let me know if I can help you. You know, honestly, at this point, you don't have to be working on math, work on whatever you want. It's $7 million. I will help you. It's a great time to get help. Yes.
You get so much money.
Apparently not.
Great. Okay.
Bird, you better not be in a hole.
Wait, what?
You better not be in a hole, probably.
I'm not in a hole. Maybe a small. Like, one problem hole. That's it.
Oh my God.
That's it. I did it.
All right. Nothing is due today. What have you turned in 42?
Yeah, we have 43 and 44.
And now 45.
45.
You're the one in a hole in here.
I've got them graded. I've got them graded. I got what I got graded. You're the one. I can't grade it. You can get it.
Bags full of small things.
We have some.
This is for my pods.
We need the pod.
This is a bunch of crap. Why would you want this?
It's a razor
There's a pencil sharpener. Pencil sharpener. Something that's one of those things you throw at the wall and break some tattoos. There's some, I don't even know what that's for.
The shoelaces.
Shoelaces? That's fun.
Yes.
It's like stamps.
See how colorful they are?
Chloe needs you.
Then why do you want to keep it? If not,
Kids like crap. Because I'm giving it to the little kids. They love it.
childhood weird off. I just throw myself in the
No, don't joke about that, Zoe. I don't think that.
Well, it's too late now.
This next governor is going from 5 or 6 to 34.
Yeah, unless you got a lot and then like, then you might. But you must keep being yourself and then like paralyzed up and then that's like where.
Not the book. Actually, I'll just show you guys on the book. You can put me on my phone.
All right.
Putting the Grey's Anatomy bit. Wait.
What is an iron
Ellie, what's an iron triangle?
Yes. What?
Why don't you hand me to us? Tell us what shot.
They cost a lot. So if I give you, and I like it,
I'll do
but if I give you, I offer you donuts.
Carrot and then we're all.
Exactly, that's exactly.
Yeah,
what
I just saw it.
Exactly.
That could be carrots, that seems almost.
Did
Did they determine that the carrots are like the universal balancing?
Something healthy, I could bring it.
Oh, yeah.
Oh, hummus is so good. Hummus, oh, it's chicken. Gross. Gross. So gross. I'll bring you some satisfying. No, a donut. That's
It's like,
No, it's not. You want another.
it's fun. It's small.
it used to be like 40 seconds.
You're only having one, you don't have That's so refreshing.
Well, donuts, that's right. That's like sunshine.
Do you want me to put it?
It was a good dinner.
You know, it's
This is Gary Hansen Finance stuff.
Well, you
How much do you
I probably created it.
Something about
Probably Okay, that's all I created. Yes.
Why does it, when I squeeze this?
Some people benefit
Big
If you were in a small container, and the walls are exposed in that's the situation right now. The thing feels like it's
That trash compactor.
It's like,
Oh yeah, Star Wars. Ah,
on the
Star Wars.
trying to get out of the trash.
Rebecca is already like, oh, if we get a ticket now, we can see it on the store. I'm like, I don't care, it's in December. I don't even like it that much. It's in December. Like, I'll go see it. It's just, it's not back then. It's not either. It wasn't worth the money. It's run down. It's boring. They should end the series now. They should have done that series. The number was greater than you did. The first one was best. Okay.
Oh, really?
Yeah, it's done.
But as the first one, people liked it because there was like a flashback, and it was cool, and you didn't know who you were gonna trust, right? But then they reused the distrust for the next 4 movies, and it just doesn't work because you already know that you can trust them.